Welcome back. Right, we're now on to the next part, which is looking at the expected value, variance and standard deviation. Okay, so the expected value is the first thing we're going to do, and basically that's just another word for the mean. Okay, so the notation that we use is either e of x, okay, x representing your random variable, okay, and e obviously is your expected value. Basically, it's talking about what is the average outcome that we're likely to get from a probability distribution. Or we can use this symbol mu, which is used in maths and sciences for various things, but in maths it's typically used for the mean. It is a Greek letter mu, or if you're American, they like to say moo, which is pretty dumb. But anyway, it's if we were to anglicise the spelling, it would be mu. Anyway, it is the resulting value expected in the long run, like an average. Okay, so it's also referred to as the mean. Alright, it's found by adding together the product of each value of x, so our random variable, the value of the random variable, multiplied by its probability. So basically, if we were to write it all out, your expected value is our first x value multiplied by its probability. Add that to the next x value multiplied by its probability. Okay, so you'd multiply those together. Then you'd multiply these together, add it to the previous. Okay, multiply those together and add them, and keep going, and that will give you your expected value. So basically it's saying the value 1 we expect 2/5 of the time, the number 2 we expect 1/10 of the time, number 3 3/10 of the time, and so on. And so on average you will get a particular value, and that's the expected value. Okay, hopefully that makes some sense. So let's do that with this particular problem. Okay, so all of those added together gives us 2.4. So what that's saying is the on average we would expect this value of x to be, in here, 2.4. Alright, let's look at the next one. Find the values of a and b of the following probability distribution if the expected value is 4.29. Okay, so we've got two unknowns here, a and b, which means we need two pieces of information. Okay, one of them we know is, remember, all of these probabilities have to add up to 1. So we can say that a plus b plus all the rest must equal 1. So we can say that a plus b would equal, what's this, 0.2, 0.4, 0.6, 0.9. 1 minus 0.9 is 0.1. Okay, so they have to add up to 0.1. The other thing is we know that the expected value is 4.29, and so if we remember that the expected value is equal to 1 times 0.1 plus etc. 2 times 0.1. Okay, so they're all multiplied together, adding those together. Now, of course, they're all adding to 4.2 equaling 4.29, our expected value. Okay, E of X. Okay, so work out all of that. So we've got 4.29 equals, that works out to be 3.9 plus 3A plus 6B. And subtract that from that, we'll end up with 0.39 equals 3A plus 6B. So we can see now we've got two equations in two unknowns, and we all know how to solve those simultaneously, and so the answer to that is A equals 0.07 and B equals 0.03. I just did that on the calculator. It's pretty quick to do it that way, and in fact, just as a reminder, for the most part in methods 4, if you need to do simultaneous equation solving, you just use your calculator to do it. Obviously in the calculator section, they're not testing your simultaneous equation solving skills. Okay, so use your calculator where you can. Alright, on to the next example that we've got here. We've got Joanne applying for a job selling mobile phones. She receives a base salary of $200 per month, so that's regardless of whether she sells anything, and she gets $15 for every mobile phone sold. The following table here is the probability distribution showing the probability of a particular number of mobile phones sold per month. Okay, and here's the probability for them. What would be the expected salary that Joanne would receive each month? Okay, so first of all, we've got here X. Okay, X represents the number of mobile phones. Per month. And we've got two possible methods that we can look at doing this as. The first here is we'll look at finding the expected value of, now let's think about how her salary is calculated. It's 15 times X, okay, plus 200. So the expected value of that happening. So basically we're looking at, oops, the sum of 15x plus 200 times the probability x equals that value of x, which we can see will be, first of all, 15 times, the first value is 50 plus 200, multiply that by 0.48 plus, and then the next one. Okay, and that comes to 15.95. So that is a dollar amount. That's her expected salary. Okay, but the other possible way we could look at it is, okay, that the expected value of 15 times x plus 200 will actually also work out to be 15 times e of x plus 200, so that you don't have to individually calculate all of these quite that way. We could just work out what e of x is, so we'll go 15 times 50 times 0.48 plus 100 times 0.32, and continue on with that. So that's those, and then plus the 200 on the end, and that works out to be 15 times 93 for the expected value of x plus 200, and that also adds up to the $1,595 for her expected salary. Okay, so we're also going to look now at variance. Variance and standard deviation are related, and they basically are measures of how spread a distribution is with respect to the mean, or the expected value. So the variance we can think of as the long run average of the square of the distance from x, our particular value, to the mean. Okay, and a large variance basically implies that the possible values are spread out a long way from the mean. A small variance indicates that the majority of the values are close to the mean. And for these sorts of distributions, the way to calculate the variance of discrete probability distributions is calculated using this rule. So e of x squared, so you square each of the x values, so square the x value, multiply it by the probability. Add it to, so it's the same as doing what we did before with the expected value, but instead of using x, we're using x squared for that particular one there. This here is the expected value as calculated previously, but then the whole result is squared. And so you just subtract the one from the other. And so to find the variance of this particular distribution, we need to find both of them. So e of x, which will be 1 times 0.15, and so on. And that adds up to 3.19, and then we need to work out e of x squared, which would be 1 squared times 0.15 plus 2 squared times 0.12, and so on. And that works out to be 11.71. So our variance, okay, is going to be e of x squared, which is 11.71, minus our expected value 3.19 squared, which works out to be 1.53 around about the 2 decimal places. Now, something to be aware of is that if we have a linear function that we're working with, like we saw previously, the variance can be, in the previous example with the salary, the variance can be found by using this particular rule here. So the variance of ax plus b can be abbreviated to a squared times the variance of x. Okay, so if we've got something like this, variance of 3x plus 2, then we can square the 3 multiplied by the variance of x to give us 81. Okay, now if we had something similar like this, variance of negative x, then that can be calculated by going the variance of 1 times x, obviously, and so we square the negative 1 and multiply that by the variance of x, which is 9, which we're given here. Okay, it's just as an example. Okay, so it's really just to be aware of. I hardly ever have seen questions relating to that, but better to be aware of it.